It's Mr. Van Dong here with week 6, day 3 of math distance learning. And today we are going to be on page 949 and we're going to model volume. Now, if we were in class, everybody would be sharing these at a table. So these are little tiny unit cubes. They're 1 centimeter by 1 centimeter by 1 centimeter. So they're a cubic centimeter. And we'd be building some things with this, but we're going to draw it instead today because of the circumstances. So what you've got a chart here, and we're going to fill this out and draw the pictures. If you want to draw along with me, you might need a separate sheet of paper. They've already drawn a lot of them down here for us, but we're going to be drawing these things and we're going to be counting how many cubes it's got in there. Why are we doing this? Because we're transitioning into a measurement called volume. When we're measuring things in the first dimension, we often talk about measuring their perimeter, the straight line distance around something, okay? And when we're talking about a perimeter, we might talk about how many feet it is to walk in a straight line, right? So if I wanted to walk all the way around Sharpstein, I could give you the length in feet that it is to go around Sharpstein. And we're going to pretend that it's 5,000. I have no idea what it is, but let's pretend that it was 5,000 feet to walk around Sharpstein. And so it's a first dimensional measurement. It's a 1D measurement because it's just feet. Shouldn't be equals. Should be an example, little error. Okay. Now, starting in like 3rd grade, you guys started measuring things in 2 dimensions where you started talking about square feet or square inches. So that's when you're measuring how many flat squares could fit on a flat space. So in this classroom right now, there are some tiles on the floor in some places, and those tiles are 1 square foot. If I wanted to, I could talk about how many tiles, how many square foot tiles I could fit in this room. And it might be something like, I have no idea. Actually, I don't build a lot of houses in my spare time, so I have no idea what the square footage of this would be. A small bed, like a kind of a normal bedroom might be like 100 square. So maybe there's like 500 square feet in here. Let's pretend that there's 500 square feet. And this little 2 right here means that there are 2 measurements being made with feet. There's a left and right measurement and an up and down. So we're making a square foot, okay? So when you're measuring something in 1 dimension, you're measuring a straight line. When you're measuring something in the 2nd dimension, you're measuring how many squares can fit inside of a flat area, okay? So your bedroom has square feet, a kitchen has square feet, a house has square footage, okay? Then there's what we're doing now, 3D. So we often think of special words for these. We often have perimeter. Ooh, perimeter. This is area, right? Sometimes called surface area because it's the surface. And then we've got a special word called volume. Now this is not volume like how loud your music is in your headphones. This is the number of units, little cubes you could fit inside of something. It's like think of it as like it's similar to capacity. Capacity is how much fluid you can fit in something. But if instead of pouring fluid in, we were neatly packing little unit cubes into it. And we could change the size of the unit cubes too if we wanted. Just like not every measurement is in feet. We could have measured something in centimeters or in miles or in kilometers. Well, we can measure something in, this would be a cubic centimeter. It's a cubic centimeter because it's a centimeter by a centimeter by a centimeter. There are 3 measurements that are 1 centimeter that make it a cubic centimeter, okay? This is bigger than that. This is 10 centimeters by 10 centimeters by 10 centimeters, which is a decameter, I think. I don't know. So it's one of those ones we don't use very often. So when we're thinking about what volume is in geometry, it's like an angry ball pit, right? So those fun ball pits, you jump in and you swim around in them and it's really fun. Except if instead of balls, it was like nasty little jagged cubes that would really hurt to dive into. Okay, so we're fitting as many of those as we can, all neatly packed. That's what volume is, and that's what we're modeling today. So we're measuring things in cubic feet. So if I was going to measure this classroom in cubic feet, so it's cubic, which would mean it's feet to the third power, because there would be every cube would be 1 foot long, 1 foot tall, and 1 foot deep. So I'm holding it in my imagination. Can you see it? Can you see that I'm holding this imaginary cube, right? There it is. It's got those 6 faces. There it is. Yeah. How many of those could we fit in the classroom? I don't know, a lot, right? There'd be a lot of them, because the ceiling is like 15 feet tall. So there's 15 up, and then how many of those columns? It'd be a lot, right? All right. So anyway, cubic feet. If, just hypothetically, if the square footage of this room was 500 feet, that would be like a base layer, right? 500 square feet. And that means that I could take 500 of the cubic feet and set them on the floor, right? So that would be 500. And then I would just need to think, well, how many layers of that could I make? If my base layer was 500 of those, and I could go up 15 feet, that would be 15 times 500, which would be 7,500. So, okay, I kind of jumped ahead there. It doesn't matter. The idea here is that the most important thing that we're understanding today is what volume is. That volume is how many little cubes you can fit in an area. And quite often, the way that we find that is that we think of a base layer, how many we could fit on the base layer, and then we extend that out, how many of those layers would be there. So let's fill out this bad mamma jamma here, and we'll go from there. So this wants us to use centimeter cubes to build a prism that it has a length of 1 centimeter, a width of 1 centimeter, and a height of 1 centimeter. So when I'm drawing, I'm going to think of length as my depth, my forward and back, and my width as my left and right, and then height is up and down. So it wants a length of 1 centimeter. It wants a width of 2. So this is a 1 by 2 by 1. That would look like this, okay? It would be 2 wide. It would be 1 long, and it's 1 high. So I just have that 1 layer. So how many unit cubes did it take to make that? That's 2. Oops, I drew an E for some reason. 2 cubic centimeters. It would take 2 of these to make that shape. That's a 1 by 2 by 1. Again, this being the length, the width, and the height. You make a cursive L when you do length in geometry, so you don't confuse it with a 1. Okay? All right, what's the next one? The next figure that they have, figure B, is a 2 by 2 by 1. So it's just like before, except that it's 2 layers deep. So it would be a little bit something like this. Ooh, that was less good. Woo. It'll work out. Okay, there we go. So now I've got something that is 2 long. Here's 2. It's 2 wide. There's 2, and it's 1 tall. There's 1. So how many cubes did it take? Took 4. Took 4 cubic centimeters to make that shape. Let's do another. I struggle with space here, I can already tell. A 3 by 2 by 2. 3 by 2 by 2. Okay, this one I'm going to have to start. I should run that up higher. So if it's 3 long, it's going to be a little bit longer than the other ones. And it's 2 wide. And it's 2 tall this time. So 1, 2 is what I'm kind of thinking of. Okay, so boom, boom, bow, boo, doo, boom, bow. Making the noises is an important part of doing this. No, it's not. I'm just kidding. All right, so now I've got right here, it's 3 long, it's 2 wide, and it's 2 tall. How many unit cubes would be in there? Now, here's a common wrong answer. counting only what you can see would be the wrong answer. I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these cubes, or counting this little square on the top and this square on the front as different cubes, when actually that would be just one cube, right? That would be one cube right here that you would be counting twice on accident. So what you need to do is think of the base layer. This base layer down here, to make the base layer, or you could think of the top as even the base layer, is 1, 2, 3, 4, 5, 6 cubes. There's 6 cubes, and then there's 2 layers of it. So that's going to be a total of 12 cubic centimeters to make that shape. All right, last one. A 4 by 2 by 2. So in this particular case, it is the same as this one, except that it's 4 long instead of 3 long. So it's still 2 wide, it's still 2 tall, but now it needs to go 4 long, like this. It's a loaf of bread. There it is. Okay, so now I've got something that's 4 long, 2 wide, and 2 tall. So the base layer would be 1, 2, 3, 4, 5, 6, 7, 8 of those cubes, and then it's double, there's 16 cubic centimeters. Where we're headed with this is a formula, and you might have already figured the formula out, and good on you if you did. If you've noticed a pattern for what these numbers are doing to result in the cubic volume, that's awesome. Now today we are drawing and counting and thinking of base layers and things like that. It's important we don't just use the formula yet. Tomorrow and on Friday, we're just using the formula. Today, we're really trying to draw these objects. We're trying to imagine them in real life. We're thinking about little tiny cubes and fitting them in there. And so that's what you're gonna do. All right, let's turn the page. It's got it's drawn one for you here, and it wants you to talk about, in the first layer, in that base layer, what is the length, what is the width, and what is the height, and then how many cubes would that be? Okay, and then answer that question for the same one for those. And then if you built all of those up, it's a lot like if I had several of these. Here's my base layer, and I could have another one and build it up, and so on, okay? So this problem, I know, well, I've been frozen for a long time. Okay, I'm back. This problem can confuse kids, which is why I'm going into it. Every year, there's some confusion. We're talking about one layer at a time, like that bottom layer, and then that second layer, and then the third, and then the fourth, and then add all of the layers together to get the total figure, which you can see there is, it looks like it's a cube, but think carefully of if it would be a cube or not, based on if it really has all of its sides congruent. Okay, proceed with following the rest of the directions. You're describing them. You're asked to describe, again, layer by layer, how many, what are the measurements of each layer of the shape of these are rectangular prisms, and then total, how many little unit cubes would it take to build the final figures? Okay, so do that, and I'll see you tomorrow.